All right, hello everyone. We are now past the halfway point of the semester. We're going to be starting with section 2, which is going to run till the end of the semester. And section 2 starts with chapters 9 and 10, both being covered in this module. We kind of combine them into one lecture because they have to do with quality, managing quality, and then evaluating, correcting, and the quantitative methods involving quality. So keep in mind that in this lecture, in general, I try to make them a little bit more concise than the PowerPoint from the publisher, but that's especially true when we combine two chapters into one. I think each one was about 50 slides apiece, and I've got maybe 48 slides on chapters 9 and 10 combined. So be sure that you're reading the book. You can check out the full PowerPoints on Blackboard. I upload those for you as well if you're interested in reading them in that way. But not everything is going to be covered in as much detail as is going to be covered in your book. Again, that's always true, but especially true when we combine chapters. All right, let's get started then on quality management. So quality is defined in our book as the ability of a product or service to consistently meet or exceed the customer's expectations. A lot of attention on quality lately because of some high-profile cases, including automotive recalls, toys that are defective, produce that's gone bad, causing foodborne pathogens, bad dog food, pharmaceuticals. It could be a hazard to the public, some of these things, right? And that can have a very high cost, much higher than had you, as a management company, taking care of quality issues before they got to the consumer, right? And those costs involve lawsuits, litigation, possible loss of repeat business, et cetera. So how do we assess quality? Well, we can look for strengths and weaknesses in our service quality, right? So quality and service is a little bit more difficult to evaluate than quality in product, because products you can inspect, you can see does it work as intended or not, but service you have to do a little bit more. So it has to do with both customer expectations and management's perceptions of those expectations. Was the service actually met? You need a lot more communication involved. You need to evaluate in different methods, which is going to take customer feedback, things like that. So what determines whether quality was met? Well, did you design the product in a way that includes or excludes features, match the intention of the design to the product, right? How well does the good or service conform to the intent of the designers? So did you actually make it the way you designed it or not? Is the product easy to use and understandable by the customer? Is the customer then going to use that product for its intended purpose in a safe manner, right? And then did you take care of quality after the sale? So if an issue arises, warranty issue, defective product, or continuing service you need to perform on that, are you taking care of those issues, right? Think of maybe a software sale. There's going to be bugs that pop up. Are you providing updates to that to match the latest operating systems, right? So after the sale services. Who's responsible for quality? You've got a list of people on the left side here, but realistically, it's everyone. Everyone in the organization has some responsibility of varying degrees. What's the benefit of good quality? Your reputation's good, and good reputation means people are going to want to buy your product over somebody else's product. Your liability costs stay low. Eventually, it comes down to higher profit potential. What are some costs of quality? Well, you've got to pay for appraisals to be done, making sure that those products are being manufactured in quality ways. You've found defects before they get out, so you're paying someone to do those appraisals. Prevention costs, so this is before the issue arises. You have total quality training, planning. You've done assessment of what your customers' needs are, and you've done quality improvement costs such as new equipment, replacing damaged or hazardous parts on machinery. You've done quality upgrades of software, et cetera, right? So preventing those defects from occurring. And then if you don't do that, then you've got failure costs. So these could be internal failure costs, meaning, okay, I've got to remake this product, I've got scrap, right? External failure cost, however, would be things that occur after the products got to the customer. So this could be your liability cost, right? You could face a lawsuit if you put out a hazardous item and somebody is hurt or killed by it, right? Automobiles, defective toys, choking hazards for small children, things you got to be extra careful of in the process. That's why appraisals are so important, and preventing defects are so important, because they can cause a harm to the general public. And once those defects happen, if your product isn't good, then you're going to suffer, lack of repeat business. They're going to tell people now that those people are going to make a choice. You're going to see reviews that are negative online. People don't choose your product to begin with, etc. There are international competitions for quality. One of them is the Baldrige competition. So the idea is to stimulate efforts to improve quality and recognize those companies that are, showing a high degree of quality. There's 6 categories listed here: education, manufacturing, small business are some of those. There's also an international organization that seeks to standardize various things around the world, and they are given a number code based on what it is they're standardizing. ISO 9000 series, so not just 9000 but 9001, 9002. The 9000 series has to do with quality management and quality assurance, and if you're going to operate internationally, then operating with companies that are ISO 9000 certified can help you make a decision that company is quality company worth your investment in their product, service, manufacturing, etc. partnership with you. ISO 14000 has to do with, is the company operating in an environmentally sustainable and ethical manner. And then ISO 24700 has to do with reusing components and e-waste and office equipment. So you've got several different certifications. There's more than just these 3. Those are the ones focused on in the book. Total quality management, TQM, is a term you're going to see a lot of for the rest of the maybe not the whole semester, but the next several chapters at least. The idea here is that everyone in the organization is in a continual effort to improve quality and achieve satisfaction. That's from every single part of the business operation. So finding out what the customer actually wants, right? Designing a product that meets or exceeds those wants. Design processes that facilitate doing it right the first time. So well-researched design so that you limit the number of defects. You're tracking your results. These same concepts go up and down the supply chain, making sure that your suppliers and your distributors are meeting the customer wants as well. And you need the top management to be involved in this and be committed, not giving up because it's tough to get going and going back to more lax ways of operating. There is a term that you're going to see called Kaizen. This is the Japanese word for continuous improvement, the idea that improvements are never ending. And this goes into TQM. This also goes into what came from what was originally known as the Toyota way or Toyota method, because Toyota was the big company in the early 1900s that sort of implemented and spearheaded all of this. And a lot of U.S. manufacturers and manufacturers around the world would take trips to Japan, tour the Toyota facilities, and adopt those same methods. And they've stayed pretty much the universal standard today, and it all came from Toyota. So you'll see a lot of Japanese terms over the next few semesters as well, and that all stems from that. Obstacles to implementing TQM. Well, how does the company actually define quality, and is there a company-wide definition that everyone can understand, right? And you might put too much of an emphasis on short-term financial profits here. You might not empower your employees to actually make decisions in the interest of quality. You might not have leaders that are really involved and they're not motivating their team as well. Now, TQM isn't a universally accepted idea. There are some criticisms. One of them would be that you focus all your attention on quality blindly, but not cost benefit analysis or other strategies, right? You may not be linked to the strategies of the organization in a meaningful way. You're saying quality, 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 but what does that actually mean? You say quality, 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 but you're not actually interested in continuous improvement, and you're ignoring your employees. You didn't carefully plan it before you embarked. So starting tomorrow, we're going to have TQM. Okay, go. What are we talking about, right? So making sure that everybody's fully on board with exactly what that means. No false starts where you have to go back to the previous status quo and then start again, etc. Six Sigma. This is a lot of businesses are real big on the idea of Six Sigma. A lot of management, leadership books written on the subject. There are certifications, Six Sigma. There are they use like karate terminology, black belt, green belt, yellow belt, or I don't know the colors to be sure, but black belt is, I believe, the highest. But they use the same idea of certification. And so you're Six Sigma black belt certified, right? It's a huge cost to learn these standards, to take the exam and to get certified, and you have to keep that certification up. But the benefit to you personally is that employers like to see that your commitment to that idea of quality, and so it often will result in higher pay or the difference between you being hired versus somebody else because you have these certifications. So they're definitely worth looking into. The term comes from the letter sigma is used in quantitative methods to represent standard deviations, how far something is statistically from the mean. And so the number of sigmas or standard deviations away would encompass X number of defects. You could say that everything within 6 standard deviations would encompass all outcomes up, 99.9999999, et cetera, percent. But the idea is statistically, you would have no more than 3.4 defects per million occurrences. So virtually perfect quality is the idea. This encompasses just about, perfect quality effectively, right? It rounds up to 100%. All right. What kind of tools can we use to measure quality? Here's some of the flow chart, check sheet, histogram, Pareto chart. We're going to be focusing on 2 in particular in this class, which are going to be the histogram, 3, histogram, Pareto chart, and control chart. We've used scatter plots in previous chapters to map out XY coordinates for quality purposes or for other purposes. Flow charts we're going to be using later on in the semester. But let's take a look at what those would mean. Let me zoom in here. So a check sheet we use as part of a histogram. So we just every day product A had 3 defects, product B had 2 defects, product C had 1 defect, right? So it's a tally sheet so that you can keep track of it electronically. We can do that nowadays. A histogram then is a type of frequency chart that shows the frequency of occurrences. But then the Pareto chart is the same way, but arranged from highest to lowest frequency. We're going to be using this Pareto chart in this week's quantitative work. And that helps to show us what areas are the biggest focus of our business, right? The top two ones here take up something like 70–80% of all of the occurrences. So they need the most attention realistically. And then a control chart we're going to be using in chapter 10 to measure, this little dotted line is the mean, the average of occurrences, and then how far does each specific occurrence deviate from the mean, and then we can see is something out of control. And we'll talk about what control means in a little bit later. So benchmarking has to do with comparing yourself to other companies, other products. So you identify a process that you think needs improvement, then you look to an organization that excels in that process or that product, contact them, analyze the data, and improve your process based on them. So comparing yourself to somebody else, am I exceeding or am I falling below a standard that's out on the market already? And then to summarize the chapter, quality is imperative for organizations at a strategic level. It's a never-ending journey. Just because a customer is satisfied doesn't mean they'll be loyal. And you still have to, I'm happy with it, but I'm not thrilled, right? Satisfaction isn't exceeding their expectations. And it needs to be incorporated not just between your organization and the departments in your organization, but everything up and down the supply chain needs to be invested in quality. All right, let's look at control of quality here in chapter 10. What is quality control? It's evaluating output relative to whatever your standard is, and then take corrective action when it doesn't meet those standards. Inspection alone is not sufficient. You need inspection along with process control to achieve the level of acceptable quality you're seeking. So inspection alone would be very blasé, not progressive at all. Inspection and then correcting during production would be kind of in the middle ground, but then building quality into the process. So is there a better way we could be doing this? Not just inspecting the results, but okay, how could we improve the results before we actually manufacture the product? So inspection is appraising the goods and services. So this came off the assembly line. Yes, it works as intended. Check. Great. But there's also processes and products along the way from the time it starts to the time it's a finished good or gets to the customer. Determining how much to inspect would be one of the issues you need to address. Where to inspect, at what point in the process? Do you take products to a control center where you test them, or do you test right there on site? Is that disruptive to your production lines? And then here you'll see, if you look at this dotted line, this is the total cost of inspection. And this orange line is how much would it cost if defects got through, right? And the blue line is the cost of inspection itself. And at some point, there is an optimal amount of inspection and to do with the cost and what you're getting for your time investment, your quality level you're seeking, and it's where these points cross over. That's where total cost is the lowest, because the cost of inspection and cost of defects cross over, so neither one of them is higher than the other. Where in the process do you inspect? Well, you'll inspect the raw materials that come in from the distributor. You will inspect finished parts, so those are the main two. Is there a process point at which you can't undo what's being done? Maybe it's items being welded together or glued together, right? That's irreversible at that point. You can't recover the materials. So inspecting all of the subcomponents before they go into the final good might be a good time to inspect along the way. Okay, statistical process control, SPC is the abbreviation there, and we're going to talk about several SPCs coming up in the next few slides. But the general idea is to help us decide, is a process in control, or if it's not, then what corrective action do we need to take to solve that? there are two questions to ask yourself. Are the variations, so if I look at all the outcomes and I'm measuring them, are these variations random? If they're random, then there's nothing I can do to correct that. That's just what's going to happen due to, the way the universe tends to work. However, if the variations appear to be non-random and we can measure them and plot them out on various control charts to help determine that, then the process is said to be unstable and we have to correct it. So is the variability, when it is non-random or random, is it still within a certain range, upper and lower control limit? And if so, is that acceptable? And right, so determining where that upper control and lower control limit, what is acceptable values there is important as part of the process capability. Variations, so random would be, again, natural variation, countless minor factors, but then assignable variation, non-random variation, you can identify it, and if you can identify it, you can correct it. There are a couple things you measure. You take the samples and you average them out for the day or the period, and then you need to also, not just the averages, but the number of occurrences is important because of various control charts. You use both the average and the number of occurrences to find certain values that you use in your formulas. And this is to judge how random the process variation is and whether or not it's acceptable. Steps, you'll see that these steps for effective control look very similar to steps for problem solving in general, right? We've covered these already: define, measure, compare, evaluate, correct, and monitor. That was the same steps from earlier in the year. And let's look at some of those control charts now. So you time order, so from period 1, 2, 3, 4, 5, or samples 1 through however many, 12, you have lined out all of your results, and then you have an upper and lower control limit within this. Let's just take a look at it. So you've got all your sample numbers in the order you've obtained those samples. You've averaged out the samples from that day. So sample number 1, you might have maybe 5 observations that day, and then you average out to get your sample for the results. Then you plot it compared to the mean. So you've got the normal, what you expect it to be, and then where that result is, it is plotted out, and you can see all these dots lie within the upper and lower control limit. However, once you get to here, this one is far too high, and you have an abnormal variation, which means you should be able to figure out where that came from. Because it's too high to be considered just normal random variation. There's something wrong in the process, or there's something wrong with your evaluation methods. Now, when it's assignable, there are 2 types of errors. Type 1 is when you say that the process is in control. However, when you say the process is not in control, but it actually is. So the risk there is said to be the manufacturer's risk, meaning the costs are that you think the product's defective, so you never ship it out. However, it could have been good, so you've wasted the time and money in producing that good. It was actually a good product, and you missed out on the opportunity to profit off of it. Type 2 errors, however, tend to be more costly, and this is when you say the process is in control, the product is not defective, right? However, it really is defective, right? So you think it's in control, but it's not in control. And the probability here, what could happen here is that you send out a defective good. Now the consumer is at risk for the hazards involved or the costs involved if they can't get things remedied in terms of cost, time, satisfied afterwards. And the cost can be much higher because, again, it can cost you repeat business. It can cost you all the return process, some kind of extra monetary costs, liability issues. So you definitely need to make sure the process is being evaluated correctly. But the type 2 error can be significantly more costly and can cause significant hazards if it's a defective issue. Two control charts that we're going to be covering in our quantitative work this week are going to be mean control charts, also known as X bar charts. X is what we typically use for the mean, sample mean, and then a bar over it would be the mean of your X's, and then we use a double bar to say that it's the average of the averages, meaning you're averaging out all the averages for a certain time period. And then a range has to do with the range from high to low, compared from your lowest observation to your highest observation, and where those fall on that compared to an upper and lower control limit as well. And for your process to be in control, it needs to be in control on your X bar chart and on your R chart. Both can be measured this way. So you've got some formulas, but this is really just saying take the average of your means and divide it by the number of observations, averaging out your sample means, and then averaging out your sample ranges. We're going to cover this more in detail on your quantitative video this week. These values A2, there is a chart you're going to see in your book, and you're going to look up the value there and plug that into the formula. So again, let's not worry too much about that right now. Same thing here on the R chart. D4 and D3 are values from this chart right here, which I don't know the book number, but the table is table 10.3 in chapter 10. You'll look up based on the number of observations. There'll be a value that you use, and you just plug it into a formula. It's a fairly simple formula once you understand how the chart works. Let's just zoom in again here. So you can see again on the X bar chart, you'll have a lower upper control limit. It's now out of the upper control limit on this one, whereas the R chart, it is within the ranges. You'd say that's in control based on the R chart, but not based on the X chart. And again, it needs to be in control on both for it to be actually in control. To determine your initial control limits, you should have a substantial amount of sample observations. 20 to 25 is generally significant. You can have more. It wouldn't hurt you to have more, but you don't want to just get 5 because they could all happen to be very high or very low, and then your samples just aren't of value. So 20 to 25 is the suggestion here. And then as far as the rest of the process goes, we're going to go ahead and save that for our quantitative video as far as what you do. I'll come back to this slide here. A couple other charts. So we're focused on X bar and R bar charts, but a P chart would be used to help check type 1, type 2 errors. If your observations aren't something that could lie on a spectrum of the means being here and here, but if you have something like good, bad, pass, fail, defective, not defective observations, then you can put them into different categories and determine the number of potential errors. But again, only if you have 2 categories for the observations only, not a continuous possible variable. And then control chart C chart would be used to measure the number of defects per unit. So this is when you can have multiple different types of defects on one unit. So number of scratches, number of chips, number of dents, how many cracks or faults, right? So a non-occurrence wouldn't be counted, but the number of occurrences on one item. So we're not going to cover those 2, but you might get asked a question about when is a P chart or when is a C chart the best chart choice on your quiz. So be aware of those ones. And then I just want to kind of conclude by going over non-randomized patterns. So assuming that there is, here we go. A trend would be where you're randomization is starting to go bad, or right, it's out of alignment. You can say it's getting worse because it's trending up or trending down. So it was working, it's working not so great, not so great, not so great. And this could be up or down. Either way is something is out of alignment, right? Cycles. Cycles is an odd one to see in production, but it could be that there's a certain potentially maybe this could be an employee maybe working on a specific shift, and when that happens, the products get a little bit different because of the way that they control the process. But you can see a wave type pattern where it goes down, then up, then down. Bias would be there's too many observations on one side of that center line. So very similar to a trend, there's something going on and it's causing a lot of low results. So not trending downward, just skewing downward. And then too varied, too much dispersion. Your observations are either high, low, high, low, high, low, right? There's something out of alignment there as well. And all of these would signal that you have something to correct in the process. These would be non-random patterns. So let's just go ahead and skip to the summary here. If the process is stable, meaning it tends to be gathered around that mean, you have to determine your tolerances, what range is acceptable, your really it's all saying the same thing. There's a lot of variability, and you need to gather what's acceptable and monitor to make sure it's in that range. Is the summary there. To improve the process, you can simplify certain measures to make them standardized, mistake proof. Hard to make a mistake if there's fewer decisions to make. Keep your equipment upgraded, and then automate where you can. And finally, quality is a primary consideration for nearly all customers. They care about quality. I'm not just going to go buy something and then say that I don't care how well it works, right? So achieving that, achieving it is one thing, but then maintaining those standards is another, and that is important to any organization. The product and service design helps to ensure that you have better quality because you've designed the quality into the process before you even begun to produce it. And then use of control charts and inspection helps determine that you are meeting that desired quality outcome. All right, that's it for chapters 9 and 10. I know it's a long one, so thanks for sticking with it. And we'll see you on the quantitative practice problems videos next.